In the next 3 days, what we're doing is we get a brief introduction to R. And for that, of course, we need to install R. So we'll get a quick installation guide. Since installing R can take a bit of time, maybe 2-3 minutes, and time is something that we don't have a lot of in this masterclass. I already have it installed, but I'll guide us through it. Also, we'll go through the basics. And the basic is something that is always overlooked in every programming language. And it's usually very boring, but it is the foundation and it's necessary for anything that we want to learn, even especially when we get to the hard part. The basics will carry us through. And part of that is we'll see how to use R as a calculator. We'll learn about this terminology called variables, functions. We'll use measure of central tendency and dispersion. Then we'll go to packages, then basic plots, grammar of graphics, then using ggplot2, which is also a package. Then in day 2, this is where it gets interesting. Today is going to be interesting, but tomorrow is very interesting also. And for that, we do with data management and visualization, mainly importing data, manipulating them, reshaping them, then a bit more on visualization. Now, this is intermediate level visualization, multivariate plots with the default control, a setting, which might seem like a strange term now, but once we get there, we understand what it does. Then also controlling axis labeling, customizing things. And for day 3, now we'll do a bit of stats and the entry level of machine learning, which is regression. So we'll learn about regression and reports. And we'll learn mainly linear regression, which is OLR, which is ordinary least squares, then multiple linear regression. Then we'll learn about Quarto. That's a package that we'll be using in this program, and it's very nice. We'll learn about Markdown, dynamic data enabled reproducible documents. That's a very terrible name, but it's just saying that documents that that's reproducible by another person. If you just give them everything, they can do it themselves. Yeah, and get exactly the same results as you got. So it's a good way to share your findings. Then maybe we'll touch on Shiny. Shiny is something for interactive web development and visualization, but I don't know if we'll touch that. We don't have the time. Then I spoke on bootcamps, which we offer. So we have a registration link here. The website is estudyassist.com/courses. You'll likely get this as a link at the end of today's presentation. Of course, the recordings will also be shared to everyone that registered. And for the bootcamp, it's going to start by July, 15th of July, and cover the fundamentals down to visualization, get to search workflows. But not just that, the main thing is we are going to have multiple times to practice in form of assignments and mini projects. And lastly, a capstone project. And boy, this bootcamp is not our first, it's the second actually. It's usually very, very useful. The last people that was part of our bootcamp, they, I think 3 or 4 out of them, it was a very small class. We always prefer small classes, so attention is paid to everyone. 3 or 4 of them already have scholarships studying abroad, and those that are working professionals, because this is not limited to students. It's also for early career researchers. Those working professionals, they earn, I think, on the average around 22,600 euros yearly, and they are not in Europe. They are in their own country. One is in South Africa. I think two are in South Africa, actually. And getting that money in South Africa is not a bad money. Yeah, so that's just the information about this program. Then, if you give me the okay, I'll move on to R itself and we'll start. Is that okay? Yep. I'm the only one doing the talking. That's not nice. Please, if you want to speak, you can unmute yourself and speak. Yeah. So to start, okay, someone has raised his hand. Yeah. Yeah, you want to speak, please speak.
Good evening. Is this recording?
Yes, the video is recorded. Yeah, it's being recorded. Yes. Yeah. So moving on, the first thing we are going to do, just going back to the outline. For day one, we start with a quick installation guide. And to install, I always like the simplest of approach, how to install R. But instead of how to install R, how download. I prefer that, how download, or you can as well just input how to install R, whichever you prefer. But I believe anyone works well. So in general, I just use how download. And once you do that, you see this link, the one by rproject.org, and you also see this one by POSIT. So I'll click on the first one and I'll move to download. You see, to download R. I hope you can see this. If it's too tiny, please, you can call my attention. So I try to make this bold. But I like to believe that this is okay. Yes, then you pick any of the cloud. After that, then you download for your laptop. I already have R installed. So, but once you click this, you just click install R for the first time. Then it will download with this. Yeah, download R 4.52 install. Now you see that it's bringing this, and I already have R installed here. So I'm not going to download this. Next thing to download is RStudio. So RStudio download, and you just click on the link by POSIT. POSIT.co is the organization that develops R. So download RStudio. Once we do this, if you are using Windows, it's pretty straightforward. You just click on this number 2. Once you click on this, it's going to start downloading. But if you are using another operating system like Mac OS, you have to go down and choose your file, the Linux file. You have to choose this also. So those are the main things we need to download. Something that might also be very important to download is called RTools. And this is, of course, it's for package development, but that is not our business. But this is mainly for some packages that require compilation. It's just some technical terms. I'll just advise you to install it. So those are the 3 things. The next thing I'll do now is try to navigate to my File Explorer, and I'll just show us how it looks like. Yeah, so downloads, and here you'll see RTools here. But now this is R. Once you click on it, it will pop up. Where's RStudio? RStudio should be here too. And this is RStudio. I'll try to just show us how the interface looks like. It's pretty straightforward. You click on next, then yes, where you want to install it. Once you click on install, start installing. I do not want to install it again. Yes, I want to create this. Then for R, you have this, the language, yes. Then just accept the next. Then also next. It shows that what I already have it. So I don't want to install it again. I'll cancel. Then the last one is RTools. It's pretty straightforward. The way we do install softwares generally on Microsoft or on Mac. Linux users, it might be a bit different because that one it might need you to write some command lines. But yes, it's still pretty straightforward. Well, we'll exit this now. So this is everything. And now I can show you what you get once you install R. To begin, let me just show you. Let me show you in a moment. I'll show you R itself. Well, for R, once I open R, okay, this is R here, R 4.5.2. Once I open it, we have something that is very ugly. To be honest, it is ugly. This is how R look like. And you can just execute basic computation. 2 plus 2, for example, 4 minus 5. You get that. Type my name is Olamide. I also have this. Very simple. It is nice. You can do a lot of things with this, but I'm not sure I want to work on this. You can as well just give me a knife to end my life. This is one of the reasons why I stopped learning Python early in time. It's because the default IDE, which is called Integrated Development Environment, like Python, is terrible. It is exactly like this. So that's why we installed RStudio to make it a bit relatable. And I'll open RStudio now. And opening RStudio, this is what we have. RStudio makes it fun to work with R in general. I will explain the interface. The thing that we saw earlier on with R is exactly this here. It's the console. So what we had when I opened R alone is the same as what we have here, which is the console. Yeah, so give me a moment. I'll just open R again, just to show us that it's almost similar. Now, if we look at this, you see our version, the year and everything, type Q to create. So it's the same thing. So I'll just create this for now. Yeah. So moving on in this masterclass, what we'll be using is RStudio and not R. If we want to compare both of them, we take R as the engine. Engines are what move the vehicles. They are very important. But you'd never enter a vehicle that is just engine alone. So we need something that is beautiful, that makes our car attractive, and also that can tell us maybe, okay, show us the dashboard, maybe our fuel, we shouldn't exhaust our fuel or things like that. So now moving to the environment, once you install R, this is the first thing you see. You see these three things. They are called panes. This side here, this side also, then the third side, which is below here. Now this is the console pane, and this is where, of course, you can just write in line and get results 2 plus 2. 2 plus 2, you also get results. Then under the console pane, we have terminal and we have background jobs. Yeah, allow. We have terminal and we have background jobs. Then also we have another thing, which is environment. Environment pane is going to show us things with variables, which is a thing that I'm going to come back to explain later. Then we have history that will show all the codes that I've written so far. Then connections, this to connect to external database, then tutorial. You can actually learn R within RStudio. So if you click on this, you can install the tutorial like that, and you can learn on your own. Then we have the file pane. Now we have files. It's going to show what I have on my, this is my document now. So this is what it's showing. Yours might be desktop. So depending. Then we have plots. Any visualization that you make is going to show under this. Then packages is going to show all the things that you've installed, all the packages you've installed. That's the thing I'll also come back to explain. Then if you need help with anything, this is where you find it. The help pane. Then we have viewer. Lastly, we have presentation. Is that all right? Okay. It seems there's a comment. Let me check that. Yeah. Let me see. So someone said that my screen is fluctuating. Okay. Is everybody experiencing that? It's just anybody experiencing
on my side?
It's fluctuating on my side. Okay. Okay. Yeah. Just tell me once it's fluctuating again, just raise your hand up. So I take it slow a bit. Yeah, but so far, any questions before I move forward? No question at the moment. Okay. Now, this is just 3 things, but RStudio usually have the fourth pane. The fourth pane, you have that once you click on this plus here. And this plus, we open the text editor, which is this. Yeah, and this is where you write your code and save your code. If you write anything on the console, which we have down here, it will not be saved. Yeah, so that's why in general, I always use the RScript. Now, that's just the main thing about the RStudio environment. Of course, there's some customization. If you want to change the theme, you can go to global option and you control it here, the settings. If you want it to be beautiful, change it how you like it. But I think for clarity, I'll just stick to the default here. Yeah. So moving on, I hope the installation is pretty straightforward, and also just the environment. Of course, some things can be confusing now about what everything that I've listed, the different windows, what they do. But once we continue in this masterclass, we'll see their uses. So to start, let's start with the basics. Yeah, that's the start in everything, and it's necessary. I remember in primary school, we do have these alphabets, A, B, C, learning the alphabets. Aside from that, we count 1, 2, 3. That's where we'll start also. But we'll start with 1, 2, 3, and we'll skip a bit. We'll just skip some classes. So we'll start with addition. So 1 plus 1, as we've done. Now, whenever I write in the console, if I execute any program or any command in the console and press enter, it runs immediately. But if I do that right here on the script, it won't run. It will just go to the next line. So to run it, you press Control Enter. It's a shortcut and it's very good. It's something that will be your best friend. So 1 plus 2, if you look at this now, you see that 1 plus 2 is 3. But since the arrangement of this would make it difficult to follow, let's change how these windows are arranged. So we go to Global Options, then Pane Layout. This is console here. I want console to be here. Then apply. And once I do that, you can follow along. So now I'm just going to drop everything else and we'll see what we have here. Yeah, so we have console and we have the script. So for example now, 1 plus 2 as I typed earlier, this is the result here. So if I move simple subtraction, 3 minus 4, we have minus 1. But aside from that, we also have alphabets. But if you just write alphabets the way they are, the way we know how to write them, let me just start for someone name. Okay, yes, I have Pascal here. Now I'm going to type Pascal's name, and once I enter Pascal, it's not working, it's showing not found. Objects not found. So to actually enter alphabets, you need to enclose them in quotation marks like this. And once I press enter, I have Pascal printed. Now, in a way, we are learning what is called data types, but we'll get there officially. So now this is just simple addition, subtraction. We've seen how to write alphabets. We enclose them in what? In quotation mark. Multiplication is also easy, 3 times. Then we use the asterisk sign for that. 3 times 5, we have 15. Division is 3 divided by 2. We use the forward slash. Then we have 1.5. I don't know, is this too small? I mean, the way the text is written, because I can increase it. I don't know, is this better for you guys? Yeah, so
yeah, that's better.
Yeah, so we can see when. Yeah, so we have 3 divided by 2 is 1.5. We've seen division, we've seen addition. There's also something that's raised to power or square. So to square, you can either do this 3 asterisks twice, then 2. It's going to give us the square. But I prefer 3 and there's a symbol. I'm looking for the symbol. This symbol. I don't know the name because it's raised to power. Raised to power 2. We also have the same thing here. I'm going to clear what I have here with Control L so it can come to the top again. And I'll just run all this. Yeah. So you can see. Yes. Now moving forward, we have what is called order of operation, and that's what we regard to as PEMDAS, BODMAS. Let me put that. Order of operations. Yeah, and for that, we have these parentheses. We have PEMDAS, as I said. PEMDAS or BODMAS. I don't know if it's something we've come across. This is parentheses, and for BODMAS it's brackets. It's just a way to teach how the mathematical operations will work. So we can also do that in R. For example, if you take 3 minus 2 plus 4 times 4, now we have 17. But if you take 3 minus 2, I just want to try this, plus 4 times 4, and I put this in a bracket, you see that we have 20. So this is following the order of operation. Yeah. I don't notice something. As I said, if you have questions, kindly write them down. But before that, you'll notice that there are this symbol, this pound symbol, or what we call the hashtag in front. Now, these are comments, and they are there to make my script, which is what I'm writing now, readable, and make it easy for you to follow and for me to follow. Because once I want to come back to this, I can follow easily. And the interesting thing about this is, anytime I try to execute this command, it's empty. It doesn't execute anything. So how we always need comments. They are regarded as comments. You always neglect comments. And as you see now, it's just showing exactly the same thing. It's not running it. But if I do this, you see that it's going to run the last command that we have here, which is this. So that's just the basics. Any question before I move forward? Questions? Okay, since there are no questions, moving forward. Next, we'll move to what is called variable. And now I'm doing something that's also annoying that I've not explained, which is showing this in start section. This is to just divide my code well, so you know what I'm working on now. You can do that by clicking on code, and you see section here, insert section at the top with Ctrl+Shift+R. So I just always use the shortcut like that. So now we have variables, and I don't know if any of you have experience with any other programming language, and if this is your first, I think it's fine. Variable is generally defined as containers. They're like, yes, containers. People like to define them as containers, but I'll say they are names. They are names that you use to identify things. For example, you know a bag is a bag because, I would say subconsciously, you've been taught that this is a bag. So in the same way, we can teach how that certain values have certain name. For example, I can say my name is equal to Olamide, like this. And now we see this here. This equal to, this is an operator. Actually, it works, and it works well. It works fine. If I click my name here, anytime I try to print my name, it always returns Olamide. Yeah. But in R, we do not usually assign variables like this. We do that using the lesser than and the dash symbol. And we put Olamide. We put whatever value you want. This and this is actually the same. But this equal to sign is mostly for function. It doesn't mean it won't work. It will work fine, but it's used mostly in function. But the default in R is the lesser than and the dash symbol. So moving forward, I'll be using this more rather than this. Yeah. So I've typed in my name now. I'm going to look up some people's name, and I'll type them. Okay. Seems okay. All right. That's band. Okay. Just shorten it. P1 as participant 1, and that will be Pascal. Then P2, participant 2. We have Rejoice. We have P3, participant 3, which is Bashir, and so on and so forth. We have a lot of people right here. So I'll just limit this. Once I press Ctrl Enter for all this, it simply just assigns it, but it doesn't return a result, if you notice. there's no results here. We are just getting a print. It's different from when we entered Pascal that is up here. Entering Pascal, it returns something immediately right here. Let me just take this up. Yeah, it returns something right here. Pascal returns something, but Pascal right here isn't returning a thing. And that's because we are assigning it to a variable. The same way, my name right here too is not returning any results. So to get the values that we've stored in the variable, what we do is what? We call the variable. And calling the variable, you can either print them, verbatim, for example, my name, print it like this, or you also you just write it directly and you press Ctrl Enter, picture it, and we have Bashir here as participant 3. Yeah, so any question before I move on? If there are no questions, any question? Okay, no question. I think this is the simple stuff then. Now, moving forward, I don't know if anybody is having the, what's it called? Let me just check here. I do have it. That's the, okay, our MasterClass. It's better to go with what we have here in the outline. So we've seen how to use R as a calculator. We've learned a bit about variables, and those are the names that are like containers, P1, P2, P3, and the rest. Also, now next we'll talk about functions. But before we talk about functions, I would like to discuss about data types. Yep. And for data types, as I said, we'll take it similar way as the same way we learned in crèche and in primary school. We'll start with the basics. Data type is one of the basics that actually mess up a lot of our work that I've seen in the world. And a lot of people actually struggle with this, especially when they want to do more complex things, because they are missing out on this very simple thing. So I'll start with data types here. Now for data types, let me take this off. Yeah, for data types, we have different types of data types. The first, we have characters or strings. We have numeric. Of course, it's having different variation. Then we have booleans. We still have other types, but I will just limit it to these 3 for now. And for characters in R, character is anything that is within the quotation mark. It can either be double or single. Any of them, it works. For example, if I say comma like this, and I put a comma in here, and I print comma right here, so we get the print. So this is a symbol, and it is saved. Interesting thing, I can also save a number as a character as long as it is within a quotation mark. I'll call this my num, then I'll save the number 345. And on running this, you see we have 345. A lot of people make mistakes here, because now if you ask them what this is, they'll say this is a number. But it's different from running 345 on its own. For example, if I run 345 here, look at this. The way this is printed is different from the way this is printed. This is having the quotation mark, while this is not having the quotation mark. And now this will introduce us to 2 important functions. The first one is type of. Of course, we'll get to functions eventually, but for us to understand what the data types are, we need these 2 functions. Type of. Type of will tell us the type of data we are working with, and class will also tell us the same thing. For example, if I put class here, my num, you see that it's a character. If I put type of my num, also see it's a character. If I try type of, instead of my num, I'm putting P1. So Pascal that is up here is also a character. Okay, let's try something else. Let's try to combine it. I'll just call this combination. Sure. And I'll put this 3, 4, 5 and some alphabets. So if I try this also, you see it's a character. The main reason is that this is a character is because it's having quotation mark. A lot of people make mistakes in this. Now, the first question, anybody that wants to answer can simply unmute themselves and answer. So this will be a short exercise. Yeah, so you tell me which is a character and which is not a character. Anybody wants to answer? Which is a character and which is not a character? Anybody? Anybody willing to
Num1
give it?
is numeric and then num2 is a character.
Are you sure? Are you sure, Pascal?
Yes. So num1 is numeric, num2 is a character.
Okay,
So,
Pascal said this. Okay, this is your answer, right? I didn't say it. You said this. Okay, any other person before we move on? Any other person?
Pascal is right. Number 1 is numeric. Number 2 is a character.
Okay, so we agree with Pascal. Okay, now what we'll do is we simply, I've run this now. What I have to do is I'll use type of because I do not know which is right. So num1, and it's showing double. But if I check the class of num1, it's showing that yes, okay, now this is a number. Why the class, sorry, the class of num2 is a character. So you guys are right. You guys are following. The numbers, we have two types. We have floats or double. I'll mostly refer to this as double. Refer to this as double. Float is for Python and the rest. Then we also have integers like this. Now, for float or double, there are numbers with decimal points. That's just the simple thing. There are numbers with decimal points. But there are also whole numbers, which is strange. But the way how generally represents numbers written in their default is they are having decimal points. For example, my num, which we wrote up here, if you check the class, if you check the type of my num, oh, sorry, not my num, num1, apologies, you see that it's double. Yeah, so if I type in another number and I check the type of the number 345.5, it is double, then type of 345 again, it's also double. Now, how do we differentiate it from integers? Integers are the real whole number, meaning they have no decimal points and everything. The way I represent this, it's used the symbol L, not the symbol, the alphabet L. We just place it in front. For example, 345 L, like this. If you check the type of, see this is what? An integer. So it has changed. It's no longer double, and it's also not regarding this as numeric also. If we check the class of 345, you see that it is numeric. But for integers, once you put the capital letter L in front, you know that this is an whole number, like that. Yeah. Any question before I move on? Okay, no question. Next, we have booleans. Booleans are they're just yes or no, true or false. Simple. True or false, yes or no. Boy or girl. But no, just true or false. That's it. So T or F, that's the thing with boolean. That means it's either true or it's false, it is yes or it is no. In R, we have 3 booleans, which is kind of confusing. but it is not, because why we can know some things and we do not know some things. There are some things we are not sure, maybe we know, we do not know. That means I don't know. What I'm trying to say is we have yes, we have no, and we have I don't know, which is a top option. Yeah, so in R, all these are represented in different ways. Yes is represented with true. This is equivalent to yes. Then false, we have no, like this. Why I don't know is represented with NA. This is I don't know. Now, this is something that is usually used to symbolize missing values, which is people that are maybe a bit into data analytics would have heard of, or if you are into research, you would have heard of it. But it's not something we're going to dwell much on. We just have T and F. And I will just show you something interesting with this, true and false. For example, you can add them together. True plus true is equals to 2. That means T represents true. And false plus true is equals to 1. That means false is 0 and true is 1. But I don't want us to dive too deep in the basics, so we should just move on. Next on, we have functions. And for that, I would like to use a simple example. Let's just try to imagine cutting an orange with our nails and our teeth all the time. All the time we pick up an orange or an onion. That would be what? Painful. Multiple times, and it will be so repetitive. So functions are like creating codes, written sometimes and defaulted in R, and other times written by other people. Yeah. But they are there to perform certain tasks. Perform that task and do that task alone. That's it. They do not complicate things. They are there for one thing and they do that alone. For example, a knife simply cuts and nothing else. It cuts. Then how you choose to cut is up to you. Maybe julienne, maybe you want to slice. That is totally up to you. So for function, the first thing I would like to introduce before we go to the measure of central tendency is just some random number generating functions. For example, to just generate numbers in the normal distribution, which is a bit of mathematical term, but you should not mind that. We use RNum, which is random normal distribution. And for this, if we check right here, we see we have n, we have min equals 0 and sd equals 1. It's already giving us the arguments of these functions. That means things we can impute. For n, we have n equals 100, then min equals 5, sd equals 0.5. Now, n means what? The number that I want to generate. How many? I want to generate 100 numbers. Then min, what is the average of these numbers? I chose 5. Then what is the standard deviation? How far do I want them to spread? 0.5. So once I run this, I have these numbers here. And that's interesting. Also, we have RUnif, which is n equals to 100. Then the minimum equals to 5. The maximum equals to 3. RUnif is used to create numbers in uniform distribution. So once I run this, okay, I'm having an error. RUnif, n is produced. Why? Run if. Oh, something I forgot to tell you guys is how to ask for help, because that's also important. Now it seems like I'm manufacturing all these functions from my head, but that's not the case. I am not manufacturing it from my head. They are pre-written, and I only know this due to extensive practice and experience. But there are some times that you do not know the function you want to use. You can simply go to Google and ask, or you can just question mark, and if you need help with a particular function, you run it and we'll get the help pop it up, showing how to use it. Okay, the uniform distribution, RUnif, N, min, and max, like this. Then you go down to the example, and it will show you how to run this. But for this, the error is likely from 3 that we have right here, because the minimum is already more than the maximum. So I can make this 30. And once I run this, I have this number here, random numbers. So I'm going to save these numbers now in a variable. I'll call this my round, and I'll save this, and I'll call this my uniform, my unif, like this. And I'll run this also. As said, there are different ways we can print this. You can enter and we are good, or we use print and write this and have this print, which is nice. So I will run this again. Just change it there. Now, the first function that we'll learn, aside from type of and class and this one, but relating to the measure of further tendency, is to check the minimum. For example, we check the minimum in my round. I'll see that the minimum number that we have here is 3.95 to something. And to check the minimum, we use min. You see that it's pretty straightforward. Min for minimum, max for maximum, like that. So if I check the maximum in my round, you see that it's 6.29. So these are some measure of central tendency. Also, we can check the average. And to check the average, we use min. When we put this, and we have 5.000. You see that it's very close to 5. But not just the mean, we can also check the median to see the number in the middle. Then we impute the function, my round. I'll say this 4.98. That's the number in the middle. I hope we do know that median and mean, they are different. Yeah, I think that's important to know. Mean is the average. Yeah, while median is the number that appears in the middle after sorting everything out. So it's they're totally different. Yeah. So we do not have mode in R. The mode that we have here is totally different. You see, it shows numeric, which is not what is expected. And mode is used to check which mode is usually to check which occurred the most, but we don't have that here in R. We have to do that manually to check which occurred the most. Usually there are functions that can help with that, but it's not categorized and used mainly for central tendency. Now we are going to move to the measure of dispersion, and that's also simple functions like the standard deviation represented with SD. Yeah, and for that, I'll just take my unif, and you see that it's 7.45. But also we have the variance, which is also my unif, which is represented by var. I'll see that it's 55.51607. Now, I think 30 minutes is up. If there are no questions, we can move to the next part. But if there are questions, please ask now, because next we are going to, let me see. Someone is unmuted. Okay, 2 people have asked. Okay, Bashir.
Okay, yes, thank you very much for the class. Thank you for the opportunity. So I just want to ask you a question. So, there is no mode in R, but there are functions that we can use to do it. So I don't know if you can walk us through that. Thank you very much.
Okay. Okay, yeah. Okay, yeah. The other question. Any other questions? Is it us, Gachi? I think there's one hand that is raised up. Emmanuel's hand is up. Or okay, maybe I'm wrong. Yes. Moving forward, you said mode, right? Normally we have things like table. Table is going to give us the frequency, and mode usually just take the highest number that appears in the frequency. That means if we have a distribution, which one appeared the most? Now, before I do that, I'll introduce us to another function, and that is the round function. Round is generally used to what? To just round up a number. For example, if I take my round, let's look at my round that we have here. See how nice this looks. Now, if I put it in this enclosure of round, and I put my round here, see that it is what? It is rounded up. Any question? I don't know, it's like someone is okay, that's good. Yeah. Now for this demonstration, to answer your question, what I'm going to do now is I'll just assign this to my round 2. Showing is my second random number. And now, once I print it, we have this. So I'll insert this in table. And once I run this, you see we have 4, 5, 6. Then we have 4 appearing 18 times. We have 5 appearing 66 times. Bless you. And we have 6 appearing 16 times. This way, we know which is which. Another thing to do is to use F table. But F table, you have to use multiple variables. But let's leave it at that. Yeah, I hope I've answered your question. Okay. Moving forward, I'm trying to check the next. Let's see. Sorry. Yeah. I want to check the next thing that we have. I don't know why this is closing down. It's possible that I've opened it multiple times. Yes, I have to check the next thing that we have. So after measure of the dispersion, we have packages, basic plots. Okay, so we have these 3 things. I'll simply copy them. Then I'll bring it here. I'll place them here. So I'll comment them out. That way I do not need to go back again. Now we have packages. The best way to explain packages is with your mobile phone. The first time we get a phone, the thing we do is we start downloading applications. We check the phone, yeah, the phone is nice, but after that, we start downloading applications. The same applications that we have on our Play Store, some of them we have on Apple Store. iOS, the download applications from Apple Store, the Android from Play Store, like that. We also have Microsoft Store for Windows. But in general, we are downloading applications there. Now in R is having like its own store too. Now if we check here, packages, we see that we have some things here. Yeah, and notice we have this cran.RStudio, cran.RStudio. Cran is like the Play Store of R. Yeah, or it's like the Apple Store, the App Store of R. So for these plots, for all these that we have here, most of them, they are stock, which means that what? They came pre-installed with R. Just like your message, the message app, you have the camera, you have also, I do not know, like other applications that comes with your phone that you have. But we have camera and some people still download Snapchat. We have message, we have the normal messaging app, but some people choose to download WhatsApp. So WhatsApp and Snapchat, yeah, packages or applications. The same way in R, we have those. And to install them in R, of course, we do not have Play Store. We use command line. We use install.packages. That's one way. But let me show you the graphical way to do it. You come to this part here under packages. Then you click on install. Once you click on that, it will show you which place do you want to install it from. You want to install it from a file, or you want to install it from CRAN, which is like your own app store. Then after that, you write the name of the package. For example, tidyverse is the name of the package. Then perhaps if you want to install dependencies, it's best to click yes. And this means that if it depends on any other application, should it install the application too? I would always say that you go for yes. So you simply install this after. And installing this, now it's bringing a warning. RTools is required to build R, but it's not currently installed. Please download and install this. We're still going to install this, but I have how to install already, downloaded already. It's not just installed. I think I showed it right here. How to visit. I'm not going to install it now. There's no point at this moment because this can work without RTools. That's a tidyverse. So for the command line, instead of using this, let's check what we have here first. When we use the graphical user interface, this that we have here, and we inputted the name, we see that it wrote out this code, install.packages. And this is exactly the thing that I wrote here, install.packages. So that is the command that is used to install. For example, I can install another package. Let me install 538. Yeah, that's the name of the package. Now, if I try to install a package without the quotation mark, it will bring an error. And that's because it needs a character. And this we've seen is not a character. Oftentimes, if we see this here, my round is an object. That's why anytime we print it, my round, you see that it comes up. Coming, let me minimize this a bit. I want to show something. Yes. Okay, now let's check this environment pane. We see all the things that, all the variables that we've run so far in the environment pane. We see my round, all this here, they are all objects. Now this is list view. If I change it to grid view, now we see them. And it's showing the type of objects. This is a character, this is numeric data type, and this is a character. And this, their sizes. Then we have history. History will show all the codes that I've written so far. That's what history is for. Yeah. So moving on. For this, if I'm to enclose it in quotation mark now, and I run it, to best prevent this warning, it's best to what? Install this package. Yeah. Okay. There are many more packages that will be used in this lesson. There's another one, the modern type. That's the name. Oftentimes, we might not get the name of these packages completely. So one thing to do is we rely on autocomplete. For example, if I keep typing this modern, it brings what? Suggestions. So I just simply scroll and I press tab. Then I select the one I want. Then it installs it like this. So these are packages. Very basic and easy. Yeah. Now moving to basic plots. I think this is where it gets very, very interesting. But before I move to plots, please, anybody with question? Any question before I move on? Questions? No question? Okay. Yeah. So, okay. Bashu, did you raise your hand?
Yes, actually. I wanted to ask, after we finish all this, I'm going to go ahead and using the functions to know probably the installer data. This my environment there is in us, so I will type questions.
Okay, we type the questions. Okay. Any other person with question before we move forward? Okay. I'll be awaiting your question. In the meantime, we'll go to plots. Yeah. For for every packages, just like our mobile phones, we have default camera, but some people, they prefer to use Snapchat and other type of camera apps to take pictures. R is also having its own default plotting package, which is plot. It's part of graphics, which is right here. If we see plots, we see the name here, then we see this thing in curly brackets. Anything in curly brackets is the name of the package. Now, graphics starts a part of what? The default packages of R. Okay, I've seen your question. You asked how we could move our own data to R directly and have it read easily, just as you generated random numbers. Okay, well, data importation is what we cover tomorrow. It's the first thing that we'll cover tomorrow. And actually, I will show us about 5 different ways to import data. 5 different ways. If you are not comfortable with using the command line like I am and some other people, some people actually do prefer to use the graphical user interface. It's pretty easy. So you can use any of them. Once you have your data, you just locate it. You can import from right here. You see import data set. So this is one that we can do. There's also another that's in the environment pane, which you can also use. Yeah. So moving forward to plots now, let's just take this as an example. Let's plot my rand, the number that I've created, my rand. And if we plot my rand, we see that it's returned like this as dots. 4.5 to 6.0, then 0, 20, 40, which actually doesn't make a lot of sense to us now. If we include a y variable, because now this is representing x variable, if we include a y variable, we have my unif as y variable, and we plot it. Now it's showing that, okay, yes, maybe there's some relationship there. And here we see we have my rand here and my unif here. But it seems this is not showing the whole of my package. So I want you to give me a moment. I'm going to exit this, then start it back shortly. Yeah, I'll save this script so it's not all lost. Just give me a moment. MasterClass scripts. And to save is Ctrl S. Please always save your scripts, always save your work. I'm going to exit this and I'll stop sharing shortly and I'll share again very shortly. Okay. Let's see. It's here. Can we see the whole of the screen now? Should be better than what is shown before. Yeah. So now we can see my rand, which is down here, and we can see my unif, which is here. So this is showing everything. Yeah. So for this plot is very, very incomplete, but we can work with it. There's something I want to show us, of course, but before that, I'm going to just include some other things to this plot. For example, X label, we use XLab, which is for what is down here in my rand. Then I'll say my random number, like this. Then YLab, which is my random or my uniform numbers, like that. Now, one thing I always want us to have in mind anytime we're learning something new, or something new in general, or be it programming or any other thing, or maybe data analytics or the rest. I want us to always ask why. I think why is maybe the most underrated question. Why am I doing this? Why do I need to know this? Should I even be here? They are important questions because it will help you know if you are going in the right direction. For example, why am I learning about the R norm, R unit, or about the basics? These are questions you can ask me, And I think you should ask me, because you are here not to just follow. You are here to, of course, get curious and also see if you will get the best from this program and why would help you do that. So please always ask your why. Yeah, so now we've done this and this is all nice. We can change the color if we choose, but I know to do more to this. We can add a label, to add a title, rather. To add a title, we use name. I'll say my numbers according to distribution. The other type, for example, we can just plot only my round 2. And just say we want it to be an histogram, then we have something like this. So these are just some of the things that we can do with basic R. Basic R, or base R. Base R plots are actually quite powerful. They can be very, very powerful, but they can also get very complex. There was a job I once did that I used base R. I wrote up to 200 lines of code. And that's because the person that does not want to use ggplot2, which is something we will learn of also. So I just had to use base R. And base R it requires some kind of learning curve to actually know how to use it, but it's really nice too. Now, before all these plots and everything, I want to explain a particular concept. And that concept, I'm going to share my screen, my other screen, because now it's necessary for us to understand what we are doing with plots and how our graphs should generally look like. People are always interested in visualizations, but they don't know that even in visualization, there are rules to it. I don't know if that makes sense to us, but in general, to everything, there are rules to it. We have to do it well, and do it according to rule, just to ensure that we are not just presenting what we think is aesthetically pleasing, but instead what is right. So that is a big difference that we'll learn in this program now. So I will stop sharing here now, and I'll share my other screen while I explain the other parts of the graph. And this will lead us to the grammar of graphics. That's what it is called, the grammar of graphics. Share your app. Okay. Yes, you can see my screen, right? Now, the grammar of graphics is like the principle that is generally used to make visuals, any visualization. Grammar of graphics. Yeah, and it believes that what, of course, in any visualization or chart, we have the data. But outside the data, we have how the data is presented, which is geo. It's having different components. But now, if you look at this, if you look at if you look at this right here, you can tell that New York is around 47 here. That's the data. And Los Angeles is around 12 or 13, or maybe 15. Let's just leave it at 13. So these are data. So you can as well just write it as New York, which I'll write as NY. New York is 47. LA, Los Angeles is 13, like that. So grammar of graphics generally believe in the rule that what visualizations are those what additions of components, with the first component being the data. The addition of components with the first component being the data, and usually it will be the part of the data you want to visualize. And in this place, what they visualize is the city and the rainfall in inches. So the city and the rainfall in inches. Now we have data. This that we're about to learn now will be very, very important once we get to ggplot2. because this is the principle that is used behind ggplot2. But it's also the principle that kind of power things like Microsoft Excel's for their visualization. Now let's look at this. If we were to dissect this, we've seen that these two, they are what? They're part of the data. But not just that, they're also what? Labels, right? With this being what? The X, and this being what? The Y axis label. Y-axis label. Not just that, we have what? Title. Okay, it's like my hand is not straight. We have title here. And for title, this is another word, component. Of course, you can also regard it as a type of label, but that's not all. We have another component here. This is what? The legend. And if you see the legend is also having what? Title. When I was looking for a visualization to use as an example, I struggled a bit because a lot of them that is out there, they're actually quite wrong. Even this visualization that we have here is also quite wrong. But as you get better in visualization, you know, okay, which is right and which is wrong. But let's leave this. Now we see this right here. These are the values here. These are the values here. This is Chicago, Houston. They are called the axis values. And usually they are tied to what? Axis values are tied to the data. I don't know if you can see what I'm doing and if it's clear. I don't know if, do you have any question or can I proceed with what I'm doing? Okay. Yeah, moving on. Now we have bars. These are what? Bars. So this is what? A bar chart. This bar chart is what is regarded to as what? A genome. It can as well be something else. It can be what? A pie chart. It can be histogram, box plot, or any other violin, any other plot that you have in mind. Line charts. But now we've seen the main things. We've seen that we have data. We've seen that we have what? Axis. We've seen that we have these bars themselves, which are what? Geomes. Not that. We've seen that we have labels, which are different types. And we've seen that we have scales. Look at this side. This 50, 40, 30. They are in what? They are in 10 graduation. 10 units graduation, meaning it's increasing by 10. This is what? The scale. Then we have scales. Of course, we have things like colors here, which is whatever we have here. We have colors. So that's just everything. Now, that's just all the components that we have in a bar chart. And this is also the same for a lot of charts. Even the most complicated ones, they must have these things. Some other things that we can see in some charts, especially those that usually look exceedingly nice, is we have text written somewhere here, somewhere around here, like Phoenix, for example. Let me undo this. For example, Phoenix is the lowest. Then they'll put a bit of history right here. They'll just continue to put a bit of history right here. Then we'll have like that block of text written somewhere here. Then it makes it look really nice. Some other times we have like the data points written here, like this is 47, this is 13, this is 21. So all these, they are still part of what we have right here, which are what the components of what makes charts in general. Yeah, do you have any question before we move to ggplot2? Any questions? Okay. People are not really asking questions. It's either you guys already have experience with this, or
can you allow the grammars to go inside so that we can screenshot? I want to take a snap of it.
You said, can I allow what?
Can you allow your screen to feature all the grammars? Yeah, exactly. Thank you.
Yeah. Okay. Once you are done, just stop. So we'll move to ggplot2. Yeah. Any other question?
Yeah, I'm done. Thank you very much, sir.
Yeah. Okay. Now I will be presenting, and we'll see how we can combine all of these which I've said in ggplot2, and we'll see how it makes sense. Actually, it will make the whole process quite easy and nice. Okay. Yeah. So now we have ggplot2. Let's look at this. Of course, I've explained the grammar of graphics. Let's look at this. We have my rank, right? My rank is a data. Then, if we want to do this, we can use qplot. Now, qplot is a part of ggplot. And before you can use ggplot in general, as it's an external application, you need to ensure that what you've installed it. If you look up here, in one of the codes that we ran, I've installed tidyverse. So as part of tidyverse, example, tidyverse right here. As part of tidyverse, we have the ggplot as a part of tidyverse. Tidyverse is like a meta package, one package that installs other packages. So if I'm going to check down here, I will see that I have ggplot2, which is this. Now to load this package, that is to use the package, I need to load it first. And to load it, I use the library command, and I just insert it there, ggplot2. And this time around, I do not need to put this in quotation mark. Yeah, because it's an object. So if we check here, if I click on this, it will load it also. But now we see that it has written what? ggplot2. But not just that, now I want to load modern drive. I want to also load, let me pick this up. I want to load 538. That's because they have data that we can use. And instead of ggplot2, let me load the tidyverse, which is having everything that I'll be needing without friction. So now in modern dive, we have a simple data. I think it's in 538. We have a data called inline safety. Now, if we run inline safety, we have this. And if we look at this, we have what? Character here. It's already showing us the data type, character, LGL, which is what? Logical or Boolean. Then we have DBL, which is double, then integer and integer. So I can decide to visualize this, for example. So to visualize this, I can take inline safety, which is the data, and I'll put it in ggplot2. Yeah. So ggplot2 is having different arguments. If I press tab, it's going to show me the arguments. But if you want to see all the arguments, you can use the args function here and just put the package name or the function name, and to show you what all the arguments. But you see that it's similar to what we have right here. What we have here is similar to what we have right here. So if you want more information about how to use this function, you can use the question mark, or you can use help. Then you put the package name here, ggplot, like that. And once you use help, you get this, and it will give you instruction on how to use this. Normally, when you are checking up for any function, the first thing you want to do is just check the title. It's very important. Then the instruction. So it will tell you, okay, what I'm doing and the rest. Then after that, you check the arguments, then you read them. Then you do not need to go to the details first. You go to the examples next, because examples will show you how you can do something easy with the function like this. Now, sample is already showing different things. Yeah. So I'll just move on. We have inline safety, which is a data. Then we also have a default data. I think is NPG, which is called the miles per gallon data. And this is a data on cars and their fuel efficiency. See fuel economy data from 1999 to 2008 for popular models of car. I don't want us to go too deep into ggplot and visualization because that's left for tomorrow. Now, so with this, let's just move. We have ggplot. Now, ggplot is having, in the previous presentation that I gave now, the data is a part of the thing that we need. So the first argument in ggplot is usually the data. And the data this time around is MPG. Then after that, I said that we do map different parts of the data. For example, we had the city, then we also have the what? The number of rainfall. That is regarded to as mapping in ggplot. Then you enclose the mapping, then you just map the different columns you are interested in aesthetic, which is AES. Now, this AES is where we define the X and the Y axis. So now we have manufacturer, and we have model, we have displacement, and different things like this. So I can take, for example, X equals to Audi. Oh, sorry, not Audi, manufacturer. Now, you might be confused where I get this manufacturer from. You know where I got it from? I got it from this data, MPG. Now, if I print MPG here, you see the column names. So the thing that I'm writing is always the column name and not the values. That means I'm not writing Audi. Instead, I'm just writing only manufacturer. Then if it's a model that I'm interested in, I'll write model. But let's just move with this. Now, what I'm going to do next is what? I'll plot this. And to plot, we had the geometric that we want. The last thing that we saw is we saw bar for the last visualization that I used to explain the grammar of graphics. We saw bar. It can be pi, it can be different thing. So let's just use bar, geom bar. And what this will do on typing this is, on entering this is, we see that it's showing what? The frequency, the count. And all I have to do is what? Just put in the data, then map it, showing the aesthetics that, okay, yes, X is what? Manufacturer, then geom bar, that's all. And now this is not bad, but it can be better. I'll say let's add a color to it. So we can add color in two places. We can either add color here. If we add color here, you have to ensure that it has to be another variable from here, this part, meaning that anything that enters here has to be from the data itself. That's what it means. So since I do not want to do that, I'll simply delete this. Then I'll put the color here. And I'll say I want coral. Which coral? Okay, coral is not a bad color. And now we have coral. If you notice, we see this, the lines right here, they have color now. Let me take this down and just use geom bar default. Oh, yeah, let me go back. Now, if we compare it, we see that there are no lines. But if we want to fill this, instead of just the outline showing the color, if we want the middle to have the color, instead of coal or color, we can use fill like this. So once I press enter, we have this. Now this color is screaming. It's not really a nice color. So I can use like Georgia blue. And now this is a warm color. Yeah, so we can add more elements to this. For example, as I showed earlier, we can add labels to it. And for that, we use labs. If we compare it to plots, plot seems like a bit straightforward. But if we want to do what I did right here with plots, I'll have to use plots. Then I'll take MPG, then access it like this, manufacturer. But that's not all. I also have to say that the type is what? A bar. And I'm confident it won't give me what I want. I can also determine the color to be what? Georgia blue. like this. And now it's showing error. The reason why it's showing error is because it expects an actual value. This was originally computed. The computation has been done by what's the name? By ggplot. The computation has been done originally by ggplot. But for plots, which is base R, you have to do it manually, then insert it. So this is what the difference right here. And this is why ggplot is actually popular. One of the reasons why it is popular. It makes your workflow very, very easy. Yeah. So moving forward, we can edit all this. We can add, for example, the X label. That's just X, and we say it's manufacturer, like this. Then the Y, frequency. If you notice, I always put a comma after. That is always used to separate arguments. And once I press enter, we have this frequency manufacturer. It has changed it. But that's not all. I can decide to add a title, and I'll call this the frequency of vehicles. Simple like this. And now we see that a title appears. But that's not all. We can also decide to do a bit more if we want. For example, now we can decide to, okay, that would be me going to the advanced level, which I do not want to do. But we can decide to change this background. You see this background now, it doesn't make it shine the way we want. So for that, we use theme. So I can use a simple theme classic. I'll see that it will present this in a different ways. There are different themes. You can use another one. Once you press tab here to show you another one. Theme gray, theme BW, theme minima. I think minima is nice. And once you press enter, we have this like this. So these are just some of the basic things. You can choose to add a subtitle if you want. For the subtitle, I'll say cars involved in the study. Then caption. Caption usually is to cite the source. So I'll say source, ggplot2 package. And once I press enter, you see that the subtitle will go under. Then this source will show you, which is something we see generally, not just in newspaper. We see this in newspaper, we see this in researches, we see this sometimes even on social media posts. Source are always included. You can as well just attribute it to yourself, like chat by Olamide Adu, like this. So it's going to change. There's more that we can do. We can change the number of how this text shows, and we can change other parts of this plot. It is very, very easy to customize everything. Now, to just show you in perspective what happens if I do not add all these parts. Now, what I'll do is I'll just take this part, I'll copy it, and I'll put it down here. And once I do that, you see that we just have empty scaffolding. That means the data is there, but we've not what's assigned the visuals to it. That means the geometric, which is this geombar. And if I add the geombar now, we have this right here. And you see that we've lost this, the other things that we've done to edit it. So we can always add, as you can see, we keep plussing things. We can add what we want. For example, if I say I do not want the thing again, I will delete this. And once I run this, I will have other things except the thing, which made it beautiful, actually. So I will what? Delete this, like this. So I do not know if you have questions before we call it a day, because I think we extended the time. Any question? Questions?
Hello.
Yeah.
Please, will you be sharing the R script and the recording?
Okay. That's a really very good question. Yeah. One thing I should show is, let me see. Oh, this is in full screen. Yeah. Now I have, let me close all this. There's a GitHub repository. Yeah, and all of this is a link that I'll be sharing because all the scripts that will be used, I will upload it to this repository, meaning you can download it, and even the data that we start to use from tomorrow, because now I remember Bashi asked question concerning importing data. You need data for that, so that data is already here. So I'll advise you to download it. To download it, of course, you have to go to github.com, or I'll just mainly give you this link. I'll give you this link. You might need to register, and I'll advise you, if you've not used github.com, please start using it. It's one of the ways you can showcase what you are doing and what you've done. The doing part, people can collaborate with you. The done part, people can see that, okay, yes, you know what you are doing. And that's why GitHub is really nice. I think people in our past boot camps which have gotten opportunities because they use GitHub. They're able to showcase what they've done. And this is not just limited to job opportunities, also scholarships, because they can showcase that, yes, I can do this. Yeah, so it's important you open this, and any projects that you want to do yourself, you can do that. So this link will be shared today. Likely very early tomorrow morning, but it will be shared no less. And this script also will be included here. I've answered your question, Pastor. Any other question?
Yes, I asked of the recording of the lessons as well.
Oh yes, the recording of the lesson will be shared also. It will be shared also. Yeah.
Okay, thanks.
Yeah. I would advise you guys to install R. You understand? I know this lesson might have been a bit of stretch, but you can just go back to it and follow the same instruction. Install R, install RStudio. Try to practice yourself. It will do a lot of good. Yeah, because tomorrow we start with data, and we have an interesting data to work with. Yeah, one that is, I think, relatable with to everyone, since one way or the other we've all studied. At least we have high school diploma. Yeah, since we have that, high school education is something that we can relate with. So that's it. If there are no other questions, I think it's best we call it a day. Any other question regarding you study assist, regarding me, regarding R, you can please ask. But we are done for now. Okay, no other questions, I guess. Okay, well, if there are no other questions, I would say let's call it a day. So you do enjoy your evening. This will be made available to you, the recording, the script. Yeah. Oh, please, one last thing. Yeah, because I think I forgot this. Now, for tomorrow class, it would be nice, for the session tomorrow, it would be nice if you download this link that I'll be sending to you. Just download it. You can download it as a zip file, and once you download it, you unzip it, save. I'll be adding the script, today's script to this, so you can see that. Once we download it, you'll see all the things that we have here, especially this data. I want you to have access to the data too, so you can practice on your own. Yeah, that's the goal. So yeah, that's all. Thank you very much for your time. I really appreciate you taking the time to be here. You enjoy the rest of your day. You have a lovely evening, and I do hope I see you tomorrow. So bye-bye. Take care, everyone.